Hello guys, welcome to the demo of Lab 2. So let us start Lab 2 by creating a virtual private network. We'll just give the name Lab 2 and the IP address being 10.0.0.0.16 and our PC is created and we'll create subnets for these. Basically, we are going to try to emulate uh, this um, this topology with four subnets. So I will create my first one being host and being in for host server, host servers and server router. Then we have router client. So, and we will specify the blocks, host 2.0, host 4.0. So basically, this is a topology. We have the host and the server. Machine will connect to the server. This will be bound to the public IP. Next will be the link between the server, which will be the Ubuntu system, and the VYOS router. So it is 10 2.0. Then we have the router and the client, which is again the VOS router and the Ubuntu system, VM, that is 4.0. Then we have the client and the host, which is a public IP one. So I will create this subnet. So basically, successfully, we have created all the four subnets, which is client host, router client, server router. We will create an internet gateway, uh, app lab to internet gateway, create this gateway. After doing that, we'll attach this to a PC. So table. This is the lab to routing table, which we'll edit. We will edit the routes, add a route, all for all connections, which is inter- the all the routes will be enabled in the routing table. Stick IPs. Before we create that, we'll have to create E2C instances. Now I'll do that. E2C right now. Now I will start creating the instances. First will be the should be a Ubuntu system, which is free tier eligible Ubuntu 22. So all this is okay. We'll create a new key pair. Let us name it app. Okay, now we'll have to edit everything. We'll have to edit the VPC. Net, it should be client host, and everything else is okay. Here we'll have to add security rules, all TCP source, then add all UDP. Work. This is the network interface for this subnet, which we have defined here, which is the client host. Since we are doing it for the client VM, we'll have to add one more network interface. So we'll have now here it will be router and the client. Uh, I will launch this instance. So one of the instances is already started, which is our client. Let's start our server. Again, Ubuntu. Server. So first will be server host server. Then everything else is okay. We will add security, all ICMP. Also, we'll have to add another network interface card. Here, the last we'll have the VYOS instance remaining. So we'll create that too. That VYOS, this is the community AMI. Edit the network. Again, this is our endpoint. Subnet can be any router client or server router. I'll check router client here. Then all this is okay. Um, then we just add security rules. All TCP VP this card. That would be, so we have finished router client, so it will be server router. Instance. Have the client up already. So we can see that we have two interfaces connected. That is 3 and 4. That is right. For the server, it is this. We have not connected is the router. We are out to. So it is all correct now. But we have to wait for the router instance to start. Okay, so we have the router instance starting. We'll be right back when we will successfully SSH into all the three machines and we'll continue our presentation. Before we can SSH, we'll have to set elastic IPs. So we will just do that. We'll allocate new elastic IP. For this, we'll have to associate this elastic IP. And it should be a network interface card. How do we find out which one? First, we'll do it for the client. Client will go here. Client with the host is the subnet with 10.0.3 point something. So I'll take this one and it is 0812. So I will take this one. I'll choose this network interface card 0812. Yeah, this one. So this will be associated. So I think we could check 10.3.83. Here, if we go, it is 10.3.83. Cool. Client is done. Now we'll allocate another one. And we'll now associate the server. Again, we'll go to the server, go to one. Yeah, this one. It is 0572. So find 0572. This is the one, and we'll associate it with it. Good. And router, we'll do it. Any one. So I will choose 0A4F. Locate, associate 0A4F. Associate. So how can we check if all the instances have been associated? So we'll reload. First we'll build the router networking, got a public IP. Next we'll see the client. It has also got a public IP. Then we have the server. It's also got a public IP. So next we will be back when we'll set up SSH connections to all the three VMs. Hello guys, welcome back. Now that we have successfully remotely logged into all of our three VMs, this is our VYOS router. This is our Ubuntu, which will be the client, and this is our server, which is running on Ubuntu. So basically, first of all, for the packets to go through the VYOS router, we'll have to make entries to the routing table. So basically now this is the routing. So these are the entries in the routing table. We'll have to add one more entry for 10.0.1/24. Similarly here too, we should see I now we'll have to add 10 dot for 10.0 dot uh, 10.0 dot 4.0 an entry. So this is the server and this is the client. Okay. Basically now I will just start by adding the entry to the routing table. So just a second. So basically this will be the type similar kind of. So what we'll have to do is sudo IP route add. So this is our client. Here for all 10.0.1, 1. Your 10.0.1.0/24 should go via a gateway over Ethernet. So I will check what is the IP address of the gateway here. Here we'll have to just do IP address. So on Ethernet, so this is the client. It will be connecting to the router on this interface, I suppose. 10.0.2 dot no, it will be connecting onto this interface, right? Because this is a client 10.0.4.190. So it will be via dot 0.4. Um, I think this will be ETH1. So we will check this. So ETH1 has, yeah, it's connected to the 4.0 subnet. And the gateway for this will be 10.0.4.190 for all this thing. We'll check if this is added. So the same thing, 10 dot 1 dot, is it 10.0.1.0/24 will be via 10.0.4.190 via ETH1. So this is done. We'll do the same thing here too. Basically, I'll just paste same command. Add for all. So here we'll add 1. So here we'll have to add the rule for, okay, I think I've made a mistake. So it should be not 1.0, it is 2.0. So I'll remove this. Just a second. So delete this. Just a small modification. It is 2.0 because we don't want to hinder the one IP addresses with this thing with 2.0. So I'll just make it 2.0. IP route add for all 10.2.0. We will send it via the default gateway. So this is this thing. Now, so we have the same thing. 10.0.2.0 will be via ETH1. I think we're good here. And the same thing I will do here too. Here 10.0. So this is the client. So it will be 4.0/24 will be via the gateway. Here it will be 10.0.2.128. This is the one. 10.0.128. And this will be a ETH1. Let us do this. Confirm IP. So ETH1 is connected to 2.0 subnet, and here it is 10.0.2.128. That is right. And all the 10.4 will go to this. Yeah, all the 4.0 will go via 10.0.2.78 via ETH1. Okay, cool. So I think for now we have done the setting, but there is one minor change we'll have to make before everything will work. So that is we'll have to make a small modification to the settings of the VYOS instance. Just a second, I will share my screen. I think now you can see the VYOS instance. Here in the router, we'll have to do a network setting change. Change source slash destination check. We'll have to stop this. After stopping this checking, we can again go back to our set of screens. Uh, Hope the screen sharing is proper. Yeah, I think now it is right. Okay. So now, since this is working, let us try to ping. It should be, we've added 2.0, right? 10.2.8, 10.0.2.8, 10. Yes, the ping is going through, but we don't know what route it is taking. I think trace route is not installed. Before that, we'll try to get the TCP dump on the ETH1, ETH0 interface because the client is sending it to this thing. I think on both the interface we can try, but I think we'll get it on ETH 0 because the client is pinging to the server, right? So I will just run TCP dump. Just a second. So please run TCP dump here on ETH0. Yeah. So then we will start pinging. Oh, okay. We can see that. Okay, I'll stop because we can observe this. So we can see that 10.0.4.207, which is the client, is sending a request to 10.0 or 10.0.2.80, which is a server. See, this is 10.2.0.80. I just put IP. So this is using this IP address interface ETH1. It is 10.0.4.207 is sending it to 10.0.2.80, and again 10.2.0.80 is replying through 10 to the VYOS itself. So since we are able to get a TCP dump of these packets, uh, we can now confirm that our topology is working perfectly. Now in the next part, we will do the check of by running iPerf.
Recording in progress.
Hello guys, welcome to the iPerf part of this lab. So I'm starting iPerf server on the server. Then we will start the client. So the command for the client goes like this. Just a second. So then dot AP will not have any bandwidth for it. So we can see that there was a connection. We'll be right back, guys. We'll solve this issue.
Recording in progress.
Okay, guys, we got to know the problem. First of all, we'll just run the hyper server, which is your TCP server. So then we will run hyper connect to the client on the default port, which is 5201. We can see that we are running TCP server and client. Here we are getting a total bit rate of 1.3 gigabits per second. Now we'll close the server. TCP. Why is it not taking any UDP pack? We'll be right back, guys. I will check for the UDP packets. What is the issue? Hello, guys. Welcome back to the IPEF part of lab 2. So let me start the IPEF server and I will connect to the IPEF using TCP. So finally, we get the bitrate of 1.2 Gbps. Next, we will do the modifications on both the client and server as specified by the professor. We introduce a delay of 100 ms on both of the systems. So we have to add on ETH1 is the interface or the same. So now I'm just putting 10.0.2.3. So RTT is around 200 milliseconds now. So we have 100 milliseconds delay on both of the sides. I think now our setting, which we have changed, has worked. So again, I will start the type of server, the client. So we can see that we transferred at a bit rate of 101 megabits per second, which is way less than our previous one, which is 1.2 gigabits per second. Uh, we'll try to force it over a bandwidth of 1. Let's see what happens. So maximum we get 90 megabits per second, which is way less than what we found before. Next, we'll add a delay and a loss of 10%. That's the same thing. It should also be over ETH1. The same thing. I will do it over. and the bitrate fell badly to 12.6 megabits per second from 90 megabits per second just because we introduced the loss of 10% on both the devices. And next, we will delete all the configurations on both devices. Both the configuration on both the systems is deleted. So next, uh, we will be uh, running this command, doing this configuration. So again, ETH1 rate would be just limited to 100 megabits per second and a latency of 1 millisecond. The burst is very high. Same thing. ETH1. Now we try to run the hyper server and the same thing. That even if we give 1G, the bitrate is limited to 92 megabits per second. Next, we'll try to set the speed. So this is a netlink error operation not recorded. I think this is due to the AWS security feature. The speed of 10 is not allowed. What does this mean? Command mean? So basically, the command means that we are trying to set the speed of the network interface to 10 Mbps. So the part of the it like setting the speed of the network interface to 10 Mbps is useful in scenarios where there is a when you want to limit bandwidth of that interface. While manually setting it, we should like have some caution. I think we should just set the network interface to auto negotiate. So it will have their own speed and we will get optimal performance. So by this, most of the demo is completed, is what I think. We spoke about the error. Now we'll delete all the configurations on both of the systems. So to the now we will try to set the same on the VYOS and try to do it. So before that, we'll try to ping and check what is the RTT. Okay, we have gained back to our old RTT, which is around 0.9 ms. Now here, since we are sending it from the client and the client is on the client is on ETH0. So we'll just set it. Next, we'll try to set up the same configurations on the VYOS. Basically, first will be the delay of 100 ms. So now we'll try to ping. I think ETH0 is right. We'll try to ping. So we have introduced 100 ms delay uh, in between using the VYOS router. Next, we will set a 10% loss. Okay, before that, we will have to run IO. So we'll run hyper. We get a bit rate around 199 megabits per second. Now we will uh, add a loss and we'll remove the delay. Same thing we'll try to send now. Since we had 10% loss, our bit rate should fall. Uh, okay, since the law delay is less, and the loss is 10%, we get a bit rate of 974 megabits per second. So we have an increased bit rate. So the next setting would be to um, delete run this. Nine zero one five. Again, we'll look and yeah, we can see the bit rate is almost similar. It is 996. It has increased. It is almost touching 1G. Now at last, we'll also try to set the speed on the VY system. See what happens. This also doesn't support not setting speed. It doesn't allow the interface to be set for a speed. With this, I think we are done with this lab demo. Thank you so much, guys.